Wait, that was a mistake. That was a mistake.
Hello, sir. We can't hear your voice.
Hello, can you hear now?
Yes, sir. We can hear.
Okay. So if you take a one model, we can divide the model's value into four categories. Like this is the predicted value by the algorithm. Then we have the actual value. Yeah? Okay. So actual value and predicted value, we can say like first here we can say true, and we can divide false. So if you take the actual value, it has an actual true value and the false value. And as well as you can say the predicted value also true value and the false value. So if you take a data set, it has data. Okay, maybe it will have like let's say 100 records. It can have 100 records, and that 100 records can go to these four categories. Like if you take the entire one, okay, 100 records, and if you match the predicted value and the actual value of the model, let's say you have the data and that one also actual value, yeah, predicted value means the algorithm predicted value. So if you some records are there, let's say some records are there, they are actually the actual value is also correct, the predicted value also correct. That means let's say the algorithm says it is 100 1.0 something, 1.0.0 is the value, and the actual value also 1.0.0, same value. That kind of values you will be able to find. That is called true. That means actual value also true, predicted value also true. Okay. But some records are there. Actual value is false, but algorithm say it is true. That means algorithm say yeah, it is there, but actually it is not there. That is called true false. Okay. Then we have sometimes predicted value means predicted value false means algorithm say false, but the actual value is true. That kind of values also you can have. Okay. Also, algorithm also say false and actual value also false. Okay. So that kind of situations also there. Okay. So this is what we call it's a matrix that we usually whenever we take an algorithm, we do this like actual value is something, predicted value is something. Actual value is the value that your data has, which is measured as data. Let's say if you take the this is data set, each record you have an actual value of the output. Right? You have all the internal values and say yes or no. That's the hard is there or not type. So the output is there. If you put it to the algorithm also says some values. And algorithm takes it and yeah, this is false pattern. Also predicted value also there. So now we have two values. We need to know whether those two values are equal or not. That's what we do with this model. So accuracy means we take the accuracy of yeah. Accuracy means if I put TP true positive means true and plus true negative, that means actual value is true, but predicted value is negative. And divide by let's say 2 positive plus 2 negative plus false positive plus false negative. Okay. So false negative means this. False positive means this one. Like that. So accuracy is all the how much the algorithm say this is true and it is true, and how much the actual value is negative, and the algorithm also say it is negative. Okay. So that is called, we call this accuracy. Okay. 2 positive plus 2 negative. Actual value is also positive. Algorithm also says positive. Then this one. Actual value also false. And this one is also, that is called 2 positive and 2 negative. Okay. Divide by this all. This is the accuracy. How much accurately it is saying. If you calculate this one, it is 76. I think it is 78. Divide by 100. So this one's accuracy is 7.8. That's how it is calculated. And it's the accuracy. Then it is the accuracy. How much accurate? So how much accurate is a true? How much accurate is a false? By the algorithm, we calculate it as how much the algorithm is accurate in the specific data. Then precision usually measures the proportion of correctly predicted positive instance correctly measured positive instance out of the instance predicted as positive. That means this one. Okay. How many positives? 65. Divide by this. How much positive over here? 77. That is called precision. Precision means out of the true values, how much the algorithm say true. How much algorithm couldn't say for true. Okay, this is called true. Sorry, this side. I'm sorry, it should be this. Actual value is true and predicted value is true. This. It is actually both said true, but the actual, how many actual values? 75 is there, it should be there. So that is usually goes with like this. Precision equals true positive divided by true positive plus false positive. This one. In the precision. How much the algorithm identified accurately and how much accurate values are there, actual accurate values are there. Okay. So this should be Actual values should be actual. So actual in a data set, we have actual values. So we are also in the predicted value, how much accuracy. Precision is this one. Okay. Then recall, also known as recall, also known as sensitivity or true positive rate, measures the proportion of correctly predicted positive instances out of all positive instances. All positive out of all positive instances, how much given. They usually how much actual positives are there before the precision recall. It focus on usually ability of the model to find positive instance. It's calculated as the number of true positives divided by the sum of true positives. Okay, I'm going to write the true positive. It should be come like this. So recall should be like this. And we have the true positive divided by true positive plus false negative is positive. How much usually it says how much actually it is predicted. Then we have F score, F1 score. F1 score means is it's a harmonic mean of precision recall. So usually it is giving the balance between the precision and the recall. Okay. Precision says like how much true percentages are. Actually, it is calculated the number of positive divided by the sum of true positives. Okay, sum of true positives like that. And then recall is how from out of all the accurate values, how much this algorithm predicted. And then F score is the F score is it is the harmonic. It provides a balance between the precision and the recall, and it's a single matrix. It's some usually, and you can say F score like this, and we do this one into we calculate in this way 2 into precision into recall divided by plus recall. This one. This is the F1 score. So we can use these scores to calculate our algorithm accuracy. This okay. So today we are going to do this for in our practical to calculate and say how much it is good. Okay. Let's go to practical. For the practical. Okay, we have imported the model, and finally we need to use the cross validation. Okay, we will do that one. Okay, these are the libraries that we need for our actual today. We run and see whether it is working properly. We will rename this one and model. So models are loaded, then what we will do is we will add another one and we will load the data set over here. That is iris data that we are going to use again for practice. So we are going to use the iris data set, then we are going to divide this one into two, like iris dot data. So we separate the data set into data and the target. Then again, we divide the model into two categories, like a test set and the training set. So we have X train, X test. And we have the Y train and Y test. And we are going to divide train, test. We are going to do this one and we are going to give the X value and the Y value and the test size usual. We are going to give it to 0.2. Then we are going to give the random state equal 42. Okay, what this one will do is, and it will use a random state and split the data set into two categories, test and train. Now you see that all are okay. Now you see that all are okay, and then we can go with importing the model. So what we do is we'll get the model first. We are going to get it like logistic regression. We're going to get that model, and we are going to pass the data with the fit first. Like this, and this one what it will do is it will pass the data, then finally we are going to predict. You know, these things we have done in the previous class. Okay, what this is doing is we are loading the algorithm model, then we are passing the data or training data first, then we are later after training the model, we are passing the test data to get the predictions. Oh. Event. So what we will do is we will set the maximum iterations to 1000 because it's logistic regression. Then it will work out. Yeah. Okay, this maximum iteration means whenever it is calculating the values, it can go with it is going with iteration. So if it goes unlimited iteration, you will get this kind of error. So I have set the iterations to 1000. That will that means it will go only the 1000 iterations. Okay?
So where's the data set?
Data set is this one. Data set we are getting it from the sklearn directly. It is having some data set. If you go to the sklearn, it is the library is providing already some data sets. Okay, so we are using that one. For the practical. Give me an answer.